Lesson 7, surface area and volume of prisms and cylinders. This should still be a review of things that we have done in junior high and a little bit in high school. So calculating these shapes should not be anything new. They should be a refresher. Okay? So, in geometry, a prism is a three-dimensional object which has two bases or ends that have the same size and shape, are parallel to one another, and each of the sides is a parallelogram. In this course, we are looking at right prisms. In a right prism, we deal with rectangles, not parallelograms. And I think I showed you the difference between a right prism and an oblique prism last year. So a right prism looks like this. This is a right prism because it makes a 90-degree angle when I set it on the ground. An oblique prism tilts over. So it looks like this, it just looks like somebody stuck it to the ground and then was able to push it and slant it over. The Leaning Tower of Pisa would be an oblique cylinder. So it's not a right cylinder, it leans over. Prisms are named according to the shape of the base. So when we deal with a prism, we deal with something like this as a prism. The rectangular faces don't name the prism. It's the bases. So the rectangle, these are lateral faces. It's the base. Whether it is sitting like this or sitting like that, this base part is what gives us the name. So what is the shape of this? So this would be called a hexagonal prism because the base is the hexagon. This is what? Triangular prism. Because even if I set it like this, the lateral faces are my rectangles, it's the triangle that forms the name, it forms the base. And then we can have a square prism, because this is a square shape. I could have a rectangular prism. A Kleenex box is a rectangular prism, because the base is a rectangle. So this would be a rectangular prism. This would be a square prism because the base is a square. And then I have this one, which we call a cube, because all 6 sides are the same. When we are calculating volume, the volume of my prisms are all the same. It's the area of the base times the height of the prism. So if you want, you could think of my triangular prism as being cut into layers. And if I knew the area of each layer and then just stack them, I'd form the whole prism. So if I can find the area of the base, the area of this triangle, multiply it by the height of the prism, that's going to give me its volume. That's the capacity. The surface area, I look at the surfaces. So if I take my triangular prism and I unfold it, I get 2 triangles and 3 rectangles. Now, sometimes the triangles are equilateral, which is what this guy is, which means all 3 of my rectangles are the same. But that's not always the case. I could have a triangular, I could have an isosceles triangle where only 2 of the sides are the same and the third side is different. So I'd have 2 of the same rectangles and a different rectangle. And then I could have a scalene triangle where all 3 sides of the triangle are different, which means all 3 rectangles would be different. If you notice, there's no actual formula for the surface area of my prism. And that's because it's simply put the area of all of the surfaces. So in a square prism, I have 6 sides. If it's a square, I have the 2 squares, and then I have the 4 rectangles that are all going to be the same. But in my Kleenex box, I have 6 sides, and they come in pairs. The front and the back are a pair, the 2 side pieces are a pair, and the top and the bottom are a pair. So organization is the key when you're trying to do the surface area of these prisms. Use abbreviations, use words, write it out, front and back, top and bottom, side pieces, the triangles, or draw a little picture so that you can help keep straight when you're doing surface area. The formulas that we do give you have to do with the surfaces, with the area shapes. So things to remember in this chapter. Perimeter is the distance around a figure. If I walk around the figure, that's going to be the perimeter. If I walk around a circle, we no longer call it perimeter, we call it circumference. And for a circle, the circumference can be calculated one of two ways. Pi times the diameter, or 2 times pi times the radius. And the reason why this formula works is because 2 of the r's equal 1 of the d's. We just separate the 2 and the r apart because of how we put math in notation. It is still correct to write it like this, where you're showing that the 2 and the r gives me the diameter. Mathematically, the way that we write it out in this form is because 2 is the number, it always goes in front. R is the variable, it always comes last. And this is a constant. It's a symbol, but it's still a number, so it's going to come before the variable. With our area formulas, most of these formulas you have seen before. All of these formulas can actually be connected to one. If I know the area of a parallelogram, other than the circle, if I know the area of the parallelogram, I can figure all the rest of them out. Because a parallelogram is pretty much the same as a rectangle. Still the base times the height. Still the same as a square, it's just the base and the height are the same measurement. So we can say it's side squared instead of base times height. A triangle is half a parallelogram. If I take this triangle and I flipped it around, there's my parallelogram shape. And a trapezoid becomes 2 triangles. So I have A times H, so the base times the height divided by 2, plus the base times the height divided by 2. The height and the H and the 2 are common, so I could pull those out, which would leave me with the A plus B. So I don't necessarily need to memorize all of these formulas. I need to know this formula and this one. And then remember what the relationship is between a parallelogram and the square, the rectangle, the triangle, and even a trapezoid. So let's jump into our first class example. What type of prism is this? Triangular. It actually says so in the question. But it is a triangular prism because it has a triangular shape. So if I'm asked to calculate the area of the base, it means calculate the area of the triangle. So the area of the triangle, how do I calculate the area of a triangle? Base times height divided by 2. So the area is going to equal base times height divided by 2. If I want to sketch that triangle out, what do I know about the triangle? What measurements can I put on this triangle that I'm going to need?
Base is 10 centimeters.
And I know that this measurement right here is 13. Is that the height? Nope. Am I given the height in my question? Can I find the height? Pythagoras theorem. So let's move this over here. So if I wanted to find Pythagoras theorem, we're going to look at it as being half a triangle now. Where this is my height, there's my 13, and what does this become? 5, because it's going to cut it in half. And it shows me that right here. So how do I use Pythagoras theorem to find h?
C squared minus B squared.
So h squared is going to equal 13 squared minus 5 squared. What is 13 squared minus 5 squared? What do you get? Do you get 144? Is that the height of the triangle?
You have to square root it, which means it would go 12.
Now that I have my height, I can use my area formula. Base, which is 12, times height, base, which is 10, times height, which is 12, divided by 2 equals 60 what? Centimeters squared. So now that I have the area of this base, I can determine the volume of the prism because the volume is the area of the base times the height of the prism. So the area of my base was 60. What is the height of my prism? 6. And what is 60 times 6?
60.
What are my units? Centimeters cubed. Cubic centimeters. And now if I look at my surface area, how do I find my surface area? What do I have to calculate the areas of?
Rectangles.
Okay, so let's start off with my 2 triangles. I already have one of them. Okay. Okay, so I now have my triangles. Now, what can you tell me about my rectangles?
There's 2 that are the same.
So I have 2 rectangles, and then I have 1 rectangle. And how you show this to me, there's several different ways that you could show your information. You could draw a picture of the rectangle. What are the dimensions of my 2 rectangles that are the same?
13 by 6.
And what is the area of a 13 by 6? 78. And what is the dimension of my 1 rectangle that's not the same as the other 2?
10 by 6. 60.
And the area would be?
60.
So then the surface area would be the sum of those values. 120 plus 78 plus 60. Which is?
258.
Are you telling me or are you asking me?
I'm doing it in my head, so I can't be for sure. I think I telling you.
You sound very hesitant.
Well,
Do we agree that it's 258?
Yes.
oh, we got it right. Oh yeah. You have to 78 times 2.
Ha. So what do I get? So this is 336? Because this 78 would now become 156, right?
Yeah.
So plus 156 plus 60. There we go.
Forgot the value.
Forgot to double.
That's fine.
These are common units that we use when we're talking about volume. In the metric system, if we were talking about the volume of a solid object, we use things like cubic centimeters, cubic millimeters, cubic kilometers. If we are talking about a liquid, we're now talking about capacity, we Liquid form for imperials becomes gallons, pints, etc. Things to remember, 1 cubic centimeter is equal to 1 milliliter. 1 US gallon is 3.7854 liters. 1 imperial gallon, because the United States and Britain have their own imperial systems when it comes especially for capacity, is 4.5461 liters. And 1 gallon is equal to 8 pints. Receptacle Inc. is a manufacturing company that makes containers of various sizes from materials such as corrugated cardboard. Did this happen yesterday?
Yeah, so he doesn't like it. Gordon.
Two companies asked Receptacle Inc. to produce containers of the same size in the shape of right rectangular prisms. Cubicle Limited needs a plastic container that is 15 centimeters long, 10 centimeters deep, and 8 centimeters high, in which to pack their 1 centimeter sponge cubes that they sell to elementary school educators. Waterworlds needs small glass aquariums with the same dimensions in which they keep their samurai fighting fish. Calculate the volume of each container and tell me whether or not cubic centimeters is an appropriate unit to represent the volume. So I'm going to give you a couple minutes. I want you to calculate the volume for Cubicle World, or Cubicle Limited. So if we calculate the volume for this container, the volume would be the area of the base, 15 by 10, by the height. What do I get? 1,200? 1,200 cubic centimeters. Is this appropriate?
Yeah.
Why?
Fish tanks are usually
This isn't the fish tank though. Cubicle Limited, that's the containers that they put those little sponge cubes that they sell to schools. Is it okay to express this in cubic centimeters?
Yeah,
Why?
because you're selling 1 by 1 cubes, or just 1 cubic centimeter.
So it's appropriate because I'm looking at solids.
Oh yeah, this is not gallons.
Would it be okay to use 1,200 cubic centimeters to talk about my aquarium?
No, because it's gallons, so it's water, liquid, so it involves gallons or liters.
Yeah. I would need to put this in either liters, milliliters, gallons, something because it's capacity. Because really, when I'm looking at an aquarium, I want to know how much water I have to put in the aquarium. Because that's going to, in the long run, tell me more information than just the volume of it. The amount of water that I have to put in the aquarium is going to tell me what I'm going to need to heat it up. The cost factor for heating it, the cost factor for keeping it clean, for having to replace the water that will naturally evaporate. So I want to know, what am I starting off with? And if you go to a pet store and you look at aquariums, they'll give you both. They'll give you the physical measurements, but they're also going to tell you the capacity, whether or not this is like a 10-gallon aquarium. For small glass aquariums for the small glass aquariums will be filled with water. The volume of these aquariums is given in liters or US gallons. So we're going to determine the capacity in both. So the information that I use is that 1 cubic centimeter is equal to 1 milliliter. So my 1,200 cubic centimeters equals 1,200 milliliters, which equals how many liters? And then I need my conversion to US gallons. So if I go up to the top where I was given some conversion factors, I have that 1 US gallon is 3.7854. So 1 US gallon is equal to 3.8754. Is that what I said?
3.785.
7854. Liters. And I have 1.2 liters, and I want to know how many gallons that is. So now I can cross multiply. 3.7854x equals 1.2 times L, or sorry, 1.2 liters. Divide. And how many gallons do I get? To 2 decimal places. What'd you get, Taylor? Did you do this or who put this in their calculator? Kate.
32.
0.32 gallons. It's reasonable because my aquarium is not very big. Have any of you seen the containers that they sell the fighting fish in?
They have to be small.
They're just a little box because the fighting fish, why are they sold separately?
Because it's
Kill
there
each
together.
other.
Because they're aggressive.
They're aggressive, so you put them in. I'm not even sure why you wouldn't put them in an aquarium with other fish because they're too aggressive. Or you'd have to make sure they're with more aggressive-minded fish. Yeah. So they're sold in small aquariums because they're one fish. They don't need a lot of room. I don't know. I'm not a fish person. So this is what I want you to work on is questions 1, A, D, E, and F, and 2, A, and C. I'll give you about 10 or so minutes. Surface area and volume of cylinders. So a cylinder is basically a pyramid that, or not a pyramid, sorry, a prism that instead of having a base that is a polygon, so like a square or a triangle or a hexagon, it has a base that's a circle. Instead of it having lateral rectangular faces, it has this curved surface to it. So when we look at calculating surface area and volume, the surface area, we think of what does this cylinder look like when I take it apart. So when I take it apart, there are my 2 circles, and then I get this rectangle. And we did this last year, and I think even last semester. So when I'm calculating the surface area, I have my 2 circles. What is the area of a circle?
R squared.
And then this rectangle is length times width. But when we're talking about the length and the width of this cylinder, the width is the height, and the length is the circumference of that rectangle, because this circumference wraps around. This length of my cylinder becomes the circumference of the circle. So if I find the circumference of the circle, I now have the length of the rectangle, and then I can multiply it by the height. And that gives me the area of that rectangle. So how do I calculate circumference? Pi times diameter. So the area of my rectangle would be the length, which is pi times diameter, times the height. So when I put this all together, I get a surface area formula that says the surface area of a cylinder equals 2 pi r squared, 2 of the circles, plus pi times diameter times h. Now formula sheets and textbooks don't give me the formula like that. They've got half of it right, but the other half they do something weird. Because in the other half they have this 2 pi rh. Where did that come from? This 2 pi rh when I have pi dh.
Because they're not doing the diameter, they're just doing
because the 2 in the R gives me the diameter. The reason why textbooks tend to use this formula is because then we're dealing with only 2 unknown variables, the radius and the height. But quite honestly, I want you to remember that the circumference of the circle times the height gives me that rectangle. And if you remember that circumference is pi times diameter, I don't care if you use this formula. If you use pi times d times h, that's good. Volume. How do we calculate the volume of a prism? Volume of a prism was the area of the base times the height. And remember when we were talking about it, I said if I could find the area of each of the layers of my triangle and then I added up all of the layers to give me the height, that would give me my volume. Well, I can do the same thing with the circle or with the cylinder. Find the area of this circle, and then if I have layers of that circle stacked upon itself, that's eventually going to give me the height of my cylinder. So the area of the base for my cylinder becomes a circle, which has an area of pi r squared times the height. That I can use as an actual formula because unlike a prism, the base of a cylinder is always a circle. Whereas the base of my prism could be a triangle, a rectangle, it could be a hexagon. So because it varies, we leave it as area of the base times the height. For a cylinder, we can actually do the pi r squared h. So at the bottom of the page, it gives you the formula. This formula right here for the cylinder, you guys can write in the one that we've developed, which is the pi times diameter times h. Not sure. Volume and surface area of a cylindrical can whose height is 15.4 centimeters and base diameter is 10.2. So volume would be pi r squared times h. If the diameter is 10.2, the radius is 5.1. So if I multiply that together, I get 1,258.4 cubic centimeters. When I calculate the surface area, I have 2 of those circles plus the diameter times the height for the rectangle. So I get 2 times pi times 5.1 squared plus pi times 10.2 times 15.4, which gives me 656.9 square centimeters. So those will be the questions that I want you to work on until next class. Good morning, 10 Commons. We are picking up lesson 7 on page 169 from the other day. We are looking at solving for a measurement given the volume. So last class we looked at calculating the volume of a prism, which was the area of the base times the height of the prism, and solving for the volume of a cylinder, which was the area of the base, which is a circle, times the height of the prism. So a commercial garbage bin is in the shape of a cube and it has a volume of 60.24 cubic meters. Determine the dimensions of the garbage bin to the nearest centimeter. Well, the thing to remember with a cube is the length, the width, and the height are all the same unit. So when I'm calculating the volume, if the length, the width, and the height are the same, it's taking that side and multiplying it by itself 3 times. So raising it to the power of 3. The volume is 60.24, and I want to determine what the side length is. So how do I get rid of this cubing? Well, the inverse of cubing is to cube root. So I take the cubed root of both sides. The cubed root cancels out the cubing, and I'm left with the side by itself. And then the cubed root of 60.24 ends up equaling 3.920 meters. So to the nearest centimeter is 2 decimal places. So I get 3.92 meters, or 392 centimeters is the length of each side. Okay. Now we look at B. The box for Toblerone chocolate bar is in the same shape of a triangular prism. Triangular faces have a base of 3.7 centimeters and a height of 3.2 centimeters. So the triangular face has a base of 3.7 and a height of 3.2. If the space in the empty box is a volume of 123.7 cubic centimeters, determine the length of the box to the nearest 10. So if you remember, a Toblerone chocolate bar looks like that. So what we're asked to calculate is this measurement right here, which we call sometimes the height of the prism. So remember, volume is the area of the base times the length or the height of the prism. The volume is 123.7, and the area of the base is that triangular face. Base times height divided by 2. So when I put that into the calculator to get my measurement, I get, where's my calculator? See if you can figure it out. 3.7 times 3.2 divided by 2, and I get 5.92. To get h by itself, I divide both sides by 5.92. And I get 20.895. So to the nearest tenth would round this up to 20.9 centimeters. That would be the length of the Toblerone bar. And finally, class example number 5. Poster companies decided that all of the posters will be shipped in cylindrical containers that has a height of 17 inches and a circumference of 2 inches. The curved surface of the container will be wrapped with a paper label containing the shipping logo. Calculate to the nearest square inch the curved surface area wrapping the container. So I have a cylindrical container. It looks like this. And what I want to calculate is I want to calculate this part in here. This is the height of my cylinder. So that was the rectangular portion of my cylinder. And the rectangular portion of the cylinder, the area of that was the circumference times the height. Well, the circumference is 2 inches. The height is 17. So when I multiply that together, I get 34 square inches would be the labeling space. So now that we've done these couple of examples, I want you to practice with questions 8, 10, 11, 12, and 15.